common math problems that you'll see in math competitions that will involve number theory and number tricks. The first one is find the units digit. Now this question looks a lot harder than it is. They're going to give you something maybe like this. 2 to the 62nd power times 4 to the 17th. Now if you try to do this in your calculator, you're probably going to get an overflow. And so what you want to do is you just want to figure out what the units digit is. There's a pattern to each and every number. 2's pattern with powers, 2 to the first is 2, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 6, 2 to the fifth is back to 32, which ends in a 2, and so forth. And so it repeats every 4. 4's pattern is 4, 16, 64, 256, so it switches back. It only has repeats every 2. A number like 5 is just 5 every time. No matter what 5 is to the power of, the units digit is always a 5. But in this case, 2 is one of these 4, and so 62 divided by 4, it has a remainder of 2, which would make 2 to the 62 end in a 4. 4 to the 17th divided by 2 has a remainder of 1, so it's 4. And so they both actually end in a 4, but if you multiply 2 4's together, it ends in a 6. And so that's the answer to this question. The second question is, how many zeros in n factorial? Well, this question seems, again, like a difficult question, but it's really not. If you think about the number 5 factorial, it's 1 times 2 times 3 times 4 times 5. The answer is 120. It has 1 0. The reason why it has 1 0 is that 2's times 5 makes a 0. Well, all numbers have plenty of 2's. For instance, 5 factorial has 3 2's, but only 1 5. And so, however, there's always plenty of 2's, so however many 5's there are is how many zeros it ends in. So 10 factorial would end in 2, and so forth. So what about a number like 135 factorial? Well, you'd simply just divide by 5. 5 divided by 135 is 27. 25, which has 2 5's in it, so you got to count the second 5, goes into 135 5 times, and that 125, which has 3 5's, so we got to count that third 5, goes in once. So we have an extra 5 there. 625, of course, is the next one. It does not go into it at all, and nothing after. So what you're going to do is you're just going to add those up, and this 135 factorial ends in an amazing 33 zeros. The third one that comes up is the factors question. How many factors does 800 have? Well, it probably has a lot. And so you could sit there and think 1 times 800, 2 times 400, and so forth. And that might take you a little bit of time, especially if that number is bigger. So there's a nice way to do this. What you want to do is do prime factorization. Work your way down. And you might know that 100 is 2 times 2 times 5 times 5. It's 10 times 10. And so 800's prime factorization is simply this. Knowing that will help us. What you're going to do is you're going to use these exponents. If you add 1 to them, the proof of this is pretty cool, by the way. You add 1 to each of them. 5 plus 1 is 6, and 2 plus 1 is 3, and you multiply. That means the answer to the question, 800 has 18 total factors that you would have had to find otherwise. So prime factorization, add 1 to the exponents, multiply those, and you have the factors. The fourth and final one that's very popular is a question that may be something like this. And they want to know the numerator and denominator, or they want you to sum the numerator and denominator of this number. Well, it's 3.36363636 over and over and again. What you want to do with a problem like this is you want to set it equal to x, and then I'm going to multiply by whatever number moves it over. So if there's 3 numbers after the decimal place, I'll multiply by 1,000, but since there's 2, I'm going to multiply through by 100. So then I have the exact same thing.